Hello guys, welcome to Backbencher Studies channel. In the last video, we have discussed how we can find out the steady state error when a given input, that is unit step input is given to the system. And based on that, we can relate with the static error constants. So in this video, we will derive the static error constants for different types of system. So let us first take a type 0 system and let us find out the static error constant, that is the kp the positional error constant, and kv the velocity error constant, and ka the acceleration error constant. So let us start our session. So we have the transfer function, we have the type 0 system. So what does it mean? We already discussed that a type 0 system will have 0 poles at origin. So we must not have any pole at origin at s equal to 0. So the sample transfer function can be written as some gain k into sum of zeros, the product of sum of zeros, like that we can write these are the zeros and these are the poles which are being in the system. So if we give the unit step input, we can write this as r of s equal to 1 by s. So then the positional error constant can be written as limit s tending to 0 g of s into h of s. So if we substitute this g of s into h of s, the transfer function of this type 0 system, so we can have this formula over here. And if we substitute the s is equal to 0 in this equation, we can have the positional error constant, which is equal to this k multiplied with z1 into z2 into z3 and so on up to the zeros, all the zeros which are present in the system, and divided by the product of all the poles in the system. So here we have a k constant k also. So put that, and we can draw the conclusion of the positional error constant for type 0 system is constant. And if we see the velocity error constant for type 0 system, we can have the transfer function. And if we substitute g of s into h of s in the velocity error constant formula, then we can see that as s is tending to 0, this s will make this velocity error constant is equal to 0. So similarly, if we also place this uh, corresponding transfer function in the acceleration error constant, we can find out the acceleration error constant as well. So the summary of this video is that for type 0 system, the positional error constant is constant, and the velocity error constant is 0, and the acceleration error constant is also 0. So that's it for today, guys. In the tomorrow class, we will be discussing about the static error constants in type 1 system. Thank you, guys. Thank you for your time. Thank you, guys.